As soon as you find a new substance, you want to know how it's made, what is the biosynthetic process. So we immediately went on to try to elucidate the pathway. We had already seen a paper by John Hibbs showing that nitrite and nitrate in macrophages might be coming from arginine. In fact, there was a good demonstration. And we said this must be an intermediate in the formation of nitrite and nitrate, but we cannot make arginine work. So I said to Richard, how much arginine the cell culture fluid has? And he told me it was an amazing, massive amount. And I said, why don't we try to make a culture without arginine, and then we give arginine and see what happens. So we culture the cells in the normal way, and then 24 or 48 hours before doing the experiment, we change the culture medium for a medium without arginine. And then we prepare our cells, put them in a cascade, and sure enough, when we gave arginine, EDRF came pouring out nitric oxide. So we, a year later in 1988, published the find, and then we did mass spectrometry experiments and so on, and published in 1988 the fact that nitric oxide was a product of arginine metabolism, and that was specifically made from the guanido nitrogen atoms of the molecule, because we had identified that by mass spectrometry. And that's the 1988 paper. This is the metabolic pathway that leads to the synthesis of nitric oxide. Nitric oxide, we found, is specifically generated from the guanido nitrogen atoms of L-arginine, which are shown here, through a series of transformations which involve the formation of this unstable intermediate N-hydroxy L-arginine. We found that the enzyme that we later called nitric oxide synthase incorporates molecular oxygen into the formation of this intermediate, and later on into the formation of L-citrulline, which is the co-product of the reaction that generates nitric oxide. During those studies, we also identified the first inhibitor of this pathway, L-NMMA, which is a monomethylated version of L-arginine, and that blocks the pathway competitively with L-arginine at two specific states. One previous to the formation of N-hydroxy L-arginine, and later on following the formation of this compound.